Good evening. Today we are going to see the problems on flange beams. Now we have first problem, that is calculate the moment of resistance of a flange section for the following data. Now we have given width of flange 1000 millimeter. Then we have given thickness of slab 100 millimeter, depth of beam 550 millimeters, effective cover 50, width of web 250, tension seal 6 bars of 20 torque, M20 and Fe415. So now whenever we will go for problems of flange section, we have always first consider neutral axis in flange. Whichever problem we have flange section, always go with this. And if this satisfies, then we have simple moment of resistance as singly reinforced section. If not satisfied, then you can go second case. And in that second case, we have to consider DF less than 3/7 of XU. And if this also not satisfied, then only you can go with DF greater than 3/7 X. You have to follow this so that you can get answer or you can analyze it easily. So now we will go with assume neutral axis in flange. And we know we have formula 0.87 FYEST upon 0.36 FCK into BF, because we have Cu equal to Tu and we have 0.36 FCK XU into BF, which is equal to 0.87 FYAST. And here we have rearranged the terms, therefore 0.36 FCK BF goes below. And then substitute the values. FY415 AST is given 1884.96. 6 bars we have, 1 bar we have, that is 314.16. And that gives us 1884.96. And then 0.36 M20 we have upon BF is given 1000. And this will gives me value 94.52 millimeter. But my flange is 100 mm. And so our assumption is correct. And once I have assumption correct, this becomes your singly reinforced beam. And you can find moment of resistance very easily by using simple formula. That is MR is equal to Cu into lever arm. Now we have to also check it that XU max we should have greater than the XU value, and 0.48D into equal to 0.48 into 500 equal to 240 millimeter, which is greater than 94.52 millimeter. And therefore we have section is under reinforced. And as section is under reinforced, we have to use 0.87 FYAST, or you can use both ways, that is 0.36 also you can use at that time. So if we will put it moment of resistance and substitute the values, and from this we are going to get moment of resistance 176.94, 0.87 FYAST in bracket D. So we have given depth of beam 550, effective cover we have 50. So small d becomes D is equal to 550 minus 50, and that comes 500 millimeters. And from this we will get moment of resistance 176.94 kilonewton meters. So this is first problem. Now we will switch over to the second problem. Now you can see calculate the moment of resistance. So calculate the moment of resistance of a flange section for the following data. So we have everything as it is, only we have made change as 8 mm 20 torque. And therefore what will happen? My neutral axis will go in web, because as my steel increases, so automatically my Cu increases, and therefore it will switch over to the web. Now we will go with formula first, neutral axis in flange. And from this I will calculate value of XU, which will be 151.84, which is greater than 100 mm. So our assumption is wrong and neutral axis lies in web. So this is most important, that neutral axis lies in web. Now we will have let DF less than or equal to 3/7 XU, means my depth of rectangular block, and that is greater than depth of flange, and this is most important for second case. So we will go for this, and that formula we know 0.87 fy, because here we are going to be, if I will write this formula, and then you can have this as 0.36 fck xu into bw plus 0.45 fck bf minus bw into df. That is stress into area. So this is bf minus bw into df, and that is equal to 0.87 fy ast. And these terms we have rearranged, and therefore we will get this value of xu, and that is equal to, substituted all values in this one, and we will get value of xu as 241.71 millimeter. Now we have to calculate 3/7 of xu. 3/7 of xu we will get 3 by 7 into 241.71, and that comes 103.59, and our assumption is correct. This is greater than 100 mm, and as it is greater than 100 mm, so we have rectangular depth of rectangular block greater than depth of flange, and therefore whole portion have same stress, uniform stress, which is 0.45 fck. And now we have to use that formula to find moment of resistance. So that means we have to go Cu1 into d minus 0.42 xu, and then Cu2 into, now we have d minus df by 2. So Cu1 we have this value, and Cu2 we have this value. And now we will substitute these values. So now you can see assumption is correct. And now we will go. This also we have to check. And XU max we have greater than 241.71, and therefore section is under reinforced. Now you can see this. So we have this first value 0.36 FCK XU BW. This will be CU1, and this will be lever arm 1. And then we have, this will be Cu2, and this d minus df by 2, we have lever arm 2. And then from this we will substitute the values. So 0.36 fck 20 to 41.71 xu bw 230, and 550 minus 0.42 into 241.71. And now here we are, you can see this depth we have not 500, we have 600, cover is 50. So 600 minus 50, we have 550, and therefore here we will get depth as 550 minus 0.42 into 241.71 plus we have this value, and this is, we have df, and this is df by 2, this portion. And from this we are going to get value of MR. So first 179.51 into 10 raised to 6 plus 346.51 into 10 raised to 6. And from this we will get moment of resistance, that is equal to 526.01 kilonewton meter. So that we have to see, means in this problem if we will see, then my depth of rectangular portion, and that is greater than the depth of flange. So we will have somewhat like this. And then you can see this. And here we have depth of rectangular portion. So that we have to keep in mind while solving the problems. We should know how we will get this. So these are the two problems related with your flange section. So now we will stop here only. So thank you.